Alright, now if I want to do the cosine, same thing as before. I'm going to use blue this time. And now we're doing the x coordinates from the unit circle. So the angle is still moving out horizontally now, and we're talking about x coordinates. So when the angle was 0 radians, the x coordinate was 1. So we're all the way up here at the top. Alright, but then all the other important points that we see are going to be the same. They're just in different locations. At pi over 6, the x coordinate was square root of 3 over 2. So that was the one that was up here. Alright, and then this was, remember, not the square root of 2 over 2. This was 2 pi over 6, which meant pi over 3. So the x coordinate is a half. Alright, and then at pi over 2, the x coordinate is 0. And then again, if you want to fill in the intermediate value right there, we get the square root of 2 over 2, which again, right underneath 3/4. Alright, and then after it, the x coordinates dip into the negative until they get down to -1 at 0. Or pi, I should say. So down here, pi will be at -1. And we'll make our way down the same way. So at 2 pi over 3, the x coordinate is -1/2. And then we get to this one. It's going to be a little bit less than 3/4. And then we're going to be right up here. Alright, and then we bottom out right here, and the x coordinates start getting bigger again. It's going to have that symmetry just like it had for sine. Alright, and then we're going to make our way back. From here, we're at 3 pi over 2, we got back to 0 for x, and then we're going to make our way back up again. So 1/2, and then right here we're just below, and then we're up here, and then finally we're back to 1. So what we end up with here, you may look at it and say, well, that looks different than what we had for the sine curve, but it's just because we started at a high point, and from 0 to 2 pi we made it back to a high point. You got to remember that this thing is going to repeat over and over and over again. So let me like group it all and shrink it down a little bit, and then if I stick it right on the end of itself and then think about it from right here to right here, now it looks the same thing as that we saw just there. Okay, but because one of them is starting at its median value, I guess I should say, and the other one is starting at its high point, they initially look a little bit different, but they're not. They're the same pattern, the same wave over and over and over. It's kind of like a shift, a horizontal shift. All right, so there's the property of cosine. So again, it's got up here of 2 pi. It starts at a high point. It doesn't start at the what we call the midline here, the middle. It starts at a maximum, and it starts going down initially. Alright, but same thing as before. The domain's all real numbers because it's just the angles. So we can just keep going around the unit circle as many times as we want to in either direction. The range is still -1 to +1. Again, the same reason. The range here is the possible x coordinates, and every single x coordinate is hit between -1 and +1 at some point on this circle. The period's 2 pi, just like before, because of one revolution around the circle. Now this is an even function. If you remember even functions, that has y-axis symmetry. So you could fold the cosine function over itself at the y-axis and it would hit back on top of itself. And y-axis symmetry means that if AB is a point on the graph, then -a, b, -a positive b instead of -a negative b is a point on the graph. So the heights stay the same when the inputs, the x's, change signs. So positive x goes in, this y comes out. Negative x goes in, that same exact y comes out. And that's true no matter where we start. If this x goes in, that y comes out. If the opposite of that x goes in, that same y comes out. Okay, so it's always preserving the same y value that we saw before when the x value changes. Alright, and then just notice if we graph them both at the same time, we see the same pattern. It's just kind of like a shift, like a horizontal shift. and there's the shift. We shift by pi over 2. Pi over 2 is 90 degrees, and that should make sense, because if I rotate 90 degrees, the y-axis becomes the x-axis, and the x-axis becomes the y-axis. Okay, so that we see that shift in there. All right. Now it's a little bit more than that. It's like a shift this way, and then it's like a flip to get the signs right, because you notice this is like shifting to the left. So the cosine is the sine function shifted to the left, pi over 2 units. So there's the cosine, there's the sine function. If we shift it to the left, we would end up right on top of the cosine function.